Today we will start with the first phase of a compiler, which is known as the lexical analysis phase. So, the task of the lexical analysis phase is to identify the valid words that we have in the input program for the language that we are considering. Now, the major challenge that we have here is that there may be different types of formatting, and that formatting is often user specific. Like one user may be putting two blanks after every word, another user may be putting one tab after every word. So, like that the formatting is up to the user, and very often to a programmer we suggest that you should do a good amount of indentation, so that the code is easily legible and all. So, this type of artistic things that are introduced in the program, so they are of no meaning when it comes to the machine code. So, they are to be handled by the first phase of the compiler, so which is the lexical analysis phase. So, here we will look into that lexical analysis phase in detail. The topics that we are going to cover are like this. First, we will discuss about the role of this lexical analyzer. Then, in the context of lexical analysis, we will introduce some definitions, tokens, patterns and lexemes. So, they will be used throughout our course to define the data items that are exchanged between different phases of the compiler. So, these tokens are identified and generated by the lexical analysis phase. Then there are some lexical errors that may occur, like maybe some word which is misspelled, like say somebody while writing say if writes fi. So, the lexical analysis tool, it can identify that type of mistakes and it can correct those errors, or at least suggest that possibly the user wanted to write if but has written fi. So, that way the user can be given some feedback, and not only identifying the error, sometimes we need to recover from the error also, like for example, getting the character f. So, the lexical analysis tool will wait to see the next character. So, next character it finds I, then it understands okay fi is some error, then it needs to convert it into if and then introduce those characters onto the input stream by replacing the original characters fi by that. So, this way there may be some error recovery scheme into that the compiler designer can think about and accordingly introduce into the compiler. Then how are these tokens specified? So, that is one important thing, and there can be different rules in the programming language that will tell us like how can we define different tokens. For example, the identifiers in a programming language, it has got a particular format. If you consider say the URL of different websites, so it has got a particular format. So, that format, or if I consider that as that entire URL as a single word, that word structure is definitely different from the variable declaration stem that we have in some programming language. So, that way we should be able to specify the desired tokens very clearly, and that should be very unique. And second thing is that after the specification phase has been done, we have to have some recognizer for that. So, specification phase, so it will define a set of rules by which the tokens will be defined, and in the recognition phase actually the lexical analysis tool, it will scan the input program to see what are the tokens that are appearing in the what are the words that are appearing in the program, and accordingly return corresponding tokens to the parser. Now, for the recognition part, so we will see the tool finite automata, which is so as I said that entire course hinges heavily on the automata theory. So, we will be using finite automata to act as a tool that can identify the tokens that are there in the input program, and to generate the words that are there in the input program and generate the corresponding tokens. And in that finite automata category, so we will look into two variants of the finite automata that are used by the lexical analysis phase. One is known as non-deterministic finite automata or NFA, another is known as deterministic finite automata or DFA. Both of them are equally powerful. However, specification strategy for NFA and DFA is slightly different. In general, we can find that NFAs are NFAs will have less number of states compared to DFA, but to visualize a DFA maybe it is easier for us, but if we can visualize the NFA, then we can get more compact representation for the tokens. So, initially it seems that DFA is the better one, but after some practice you will find that it is easier to construct NFA than to construct a DFA, and DFA often have large number of states compared to NFA. So, complexity of DFA may be more, though their capabilities are same. NFA and DFA, they are perfectly equivalent to each other. Then we will look into one tool that was originally introduced with the Unix operating system known as LEX. So, which given a specification, so it can generate a lexicon analyzer program for some language. So, for a language, so you can define its the rules defining the words of the language and then feed it to the LEX tool, and the LEX tool will come up with a program lex.yy.c, which is a C program, which can be used by the compiler designer to automatically generate the lexicon analysis part. So, you do not need to write explicit code for the lexicon analysis tool, because the language may be very complex, the input programming language may be very complex. So, writing the corresponding lexicon analyzer from scratch may be difficult. So, this tool actually helps us, and it has become so popular that nobody thinks in a different way apart from writing the lex specification and generating the lexicon analyzer automatically. Finally, we will conclude the discussion. So, we start with the role of lexicon analyzer. So, as you see, this tool takes the input source program of some language, and it will scan through this program, and accordingly it will generate tokens. And as I said previously, that this lexicon analyzer and the parser, they work hand in hand, and they are not so the demarcation line between the two is very thin. Okay. So, the way it operates is that this parser, whenever it requires some further token, it will request the lexicon analyzer tool to give it the token and give the next token. So, in turn the lexicon analysis tool, it will scan the input file wherever it was the input program, wherever it was scanning previously from that point onwards, and accordingly it will identify the next valid word that appears in the input program of the language and returns the corresponding token to the parser. So, what is token? So, we will come very shortly to the definition. For the time being, you can just take it as if this is some quantity which corresponds to the valid words of the programming language, and each valid word has got a different token identifier. Now, this parser in turn, so it gets the tokens, and accordingly it understands it checks whether the program is syntactically correct or not, the entire program. So, this lexicon analyzer tool is giving it words, and the parser is actually checking for sentences. So, if the sentences are correct, then it will give it to the semantic analysis tool, which will do the type checking, which will do say your other associated actions, the meaning of the program it will try to identify, and then it may go to code generation phase. Both lexicon analyzer and parser, they utilize this symbol table data structure. So, as I said previously, that symbol table stores all the identifiers that we have in the program, and so this lexicon analyzer, whenever it finds a new identifier, it informs the symbol, it puts it into the symbol table, telling that okay, this is the next symbol that we have, and it is put into the symbol table, and the parser, whenever it needs the reference to any symbol, so it will refer to the symbol table. So, who will populate the symbol table? So, that is often a choice of the compiler designer. Sometimes it is done by some compiler designer will put the job onto the lexicon analysis phase, some will put on the parser phase, depending on the ease of programming and type of language. So, different approaches are taken by different compiler designers. Now, as I said that this lexical analysis phase and the parsing phase, they are working hand in hand. So, why should we separate them into two different phases? Why not design the entire thing together? So, there are three basic reasons for doing it. First of all, simplicity of design. So, actually this whole compiler can be designed as a monolithic software, monolithic piece of program, where starting from the lexical analysis till code generation, everything or even the code optimization, so everything can be done together. But that will make the whole program very complex. So, just to avoid it, just to avoid that complexity, so we have got simplicity of design. So, that this lexical analysis phase, if it is separated, then some portion or some actions, so they are separated into a different phase. So, designing that phase become easier for the compiler designer. It improves compiler efficiency, because now these later phases of the compiler, they need not work with the input stream or the input character strings that I have in the input program. So, they can be working with some tokens, and we will see very shortly the tokens are each token is given some integer identifier. So, you can say that the later part of the program of the compiler of the compiler that is designed. So, they will be working with integers, and as you know, if we have a program that does number crunching, that is often much simpler to design compared to a program that uses character strings and does some manipulation around them. So, that way this compiler efficiency improvement. So, this is better if we have got this lexical analysis on a separate phase. It also enhances compiler portability. So, from one system to another system, so if we want to port the compiler, then take the compiler to some other system, then the formatting, the input format may be slightly different onto the target system. So, there so those things can be taken care of by the lexical analysis phase itself. So, the later phases of the compiler, they can be kept as it is, only the front end part, so that needs some changes and it can be done. Maybe from one for the same language, if we go from one platform to another platform, maybe the syntax will the way in which words are defined may be slightly different, and those things can be taken care of by the lexical analysis phase itself. Coming to the definition of tokens, patterns and lexemes, a token is a pair, a token name and an optional value. So, every token is given a name and it has got some value. The value is integer, and most often this token name and that we have. So, it is given as it is also given as integer, and this token value part. So, it may be consisting of it may be consisting of some attribute of the token. A pattern in turn, so a pattern is a description of the form that the lexemes of a token may take, whereas a lexeme is a sequence of characters in the source program that matches the pattern of a token. So, this lexeme is lexeme is the input string that is read from the input file, and we have got some patterns that are valid for the program. For example, if I say that my identifier in my programming language is like this, any sequence of character and any sequence of character and numbers, any sequence of characters and numbers, but the first symbol there must be a character. So, if I have got something like S 1 2 3 4, so this is a variable in that as per my definition, then say but say 1 S, so this is not a variable, this is not a variable. So, in my in the input program, if I get S 1 2 3 4, so this is the lexeme that you are getting. So, this is the lexeme, a sequence of character in the source program, and the pattern is, I am telling I will say how do I specify this pattern, but pattern is actually telling a rule by which I can define what are valid lexemes. Like here I am telling that any sequence of characters such that the characters and numbers such that first symbol is a character, is will define a variable. So, as per my definition, so this is a valid definition, valid variable, but this is not a valid variable. So, this is the pattern. So, how do we write a pattern, that we will see shortly, but somehow it will capture this rule. And now, after getting this lexeme matching with this particular pattern, so which pattern is called the variable, So, after this this lexeme S1 2 3 4 matches with the pattern variable. So, what is returned is the token. So, this token name, so this is often taken as integer, and this there can be an optional token value. So, which is often called attributes also. So, each token has got a value and then or a name and a value or attribute. So, in the compiler designer may give that variable the corresponding number may be say 45. So, on getting this S1 2 3 4 on the input string, since it is matching the pattern of character number sequence for variable. So, the compiler the lexicon analyzer will return this token name as 45, and as a value it can return the symbol table location for the variable S1 2 3 4. So, this way, depending upon the token that we can have a value, that is the name, and attribute or token value. So, that way it can that pair can be there. So, it can be a token name and token attribute, and name is often it is an integer, but that is not mandatory. Some compiler designer may use token names as some other format also, may not be integer, but in general it is taken as integer, and the lex tool that I am talking about. So, that also takes it as integer. So, coming to the some example, like say this particular pattern. So, characters I and F. So, this is a pattern. So, this is the lexeme. So, that is appearing in my input string, and accordingly the token that is returned is if. So, though it is written as a character string IF, but you can understand that this what I want to mean is something different than this one. Similarly, when it is say characters ELAC, the formal informal description of the lexeme is ELAC, these 4 characters coming together. The sample lexeme is ELAC, that so this thing appears on the input file. So, this matches with this particular rule, that is a character sequence ELAC. So, this matches in the with the so this input sequence matches with this particular pattern, and then it will return this as the token. And as I said that the may be, so all these tokens they are given some numbers. So, this may be say 45, this may be 46. So, like that randomly some values, some integer values, unique integer values may be assigned. Similarly, so say all these symbols less than, greater than, less or equal, greater or equal, equality, equality and not equality. So, so these are this defines another rule. Okay. So, this defines another rule or another pattern, and some sample lexemes that appears in the input program may be this less or equal or not equal to. So, these are appearing on the input file as sample lexeme, and now the token that is returned is comparison. So, this comparison token may be given the number say 47, and the lexicon analysis tool. So, when the parser asks for the token, if it gets on the input file less or equal, the lexicon analysis tool will return the value 47 to the parser, but that is not sufficient because I need to tell which comparison operator I am talking about. So, accordingly it can have some attribute part, the token can have some attribute part, and there somehow we tell that I am talking about this symbol. Maybe each of them is again given a code. So, this is 0, this is 1, this is 2. So, like that each of them may be given a code, and that code may be returned as the attribute of the token comparison. Similarly, so for say for identifier, the rule may be letter followed by letter or digits. So, this is the rule. So, this is the pattern that I am talking about. So, this lexemes that appears in the source program may be pi, score, D2. So, these are some character strings appearing on the input program. So, since the lexical analysis tool, when it finds pi, so it finds that there is no rule that defines the corresponding pattern pi, but this particular rule matches. Okay. So, this cell it because matches because it starts with a letter and it continues with letters or numbers, letters or digits. So, this part matches. So, it will return the token ID, but it has to do something more, because this pi, most probably pi is a variable. So, it will you put it into the symbol table, and as an attribute part. So, it may return the symbol table offset to be used by the parser. Some numbers. So, this is say 3.14, so 14159. So, this appears in the input program, or say something like this. So, the rule that I have is any numeric constant. So, this is the pattern, okay, and accordingly the token returned is number. So, here also token is number, but the token does not talk about the value that is actually there. So, this token has got two parts, as I said. It has got a identity, the token ID and the attribute. Okay. So, token ID or token value and then attribute part. So, this ID is, suppose here the corresponding token number that is given is say 52. So, this ID value is 52, and in the attribute part we return the actual value. So, maybe 3.14159. So, that parser, if necessary, so it will check the grammar rule, whether for checking the grammar rule it will look into the token ID, but for doing some code generation and all, maybe it will need this attribute value. So, that also it can do. So, this is how this parser and this lexicon analyzer will work together. So, literal is anything that surrounded by double quote, anything but surrounded by these double quote symbols like code dump. So, this is sample lexin. So, this is the literal. So, this way this lexical analysis tool, so it will be looking into the rules that we have. So, we have not yet seen how to capture this informal description part by means of pattern rules. So, that we are going to see very shortly. Once that is done, so this for the language I can define a set of rules that can define that can guide valid lexemes that can be there. Now, the lexical analysis tool will scan the input file and it will identify lexemes that are occurring in the program, and accordingly it will return the corresponding token to the parsing phase. So, this is how this whole thing will work. Like say when I talking about attributes of tokens, suppose I have got this particular string appears in my program E equal to MC square. So, it appears in my program M into C, then 2 star, then 2, this whole thing appears in the input program somewhere. So, lexical analysis tool, so it will start scanning from. So, when the parser has asked it to return next token, at that point the lexical analysis tool might have seen up to this much in the program. So, it has seen up to this much. So, it scans the input and it finds the symbol E, and after that there is equality. So, if it scans through the valid lexeme rules, valid pattern rules that are there in the program, that are there in the language, and it finds that E, it can be an identifier. So, it will return the token ID, and as the value part or attribute part, so it will return pointer to the symbol table entry E. So, the variable E must have been defined previously in the program. So, accordingly when that point it was the variable E was seen, so it was put into the symbol table. Now, sometime later when this line E equal to MC square comes, then the lexical analysis tool gets the symbol E and it identifier E, and it can search through the symbol table, find out what is the offset of E in the symbol table, and it can return that pointer to symbol table for E to the parser. So, this is the token value and this is the token attribute. Now it finds, so next time the parser asks the lexical analyzer to return the next token. So, at that time it will find this equality as the next token, and equality is the token, the corresponding token name is assign op. So, this it returns the token assign op. So, we do not need any other attribute for this particular token. So, no attribute is mentioned. Next, when it is asked, so it will find this m. So, it will return id and pointer to symbol table entry for m. Then it finds next token is star. So, it will return the multiplication operator. Then it will be finding the next time it will find this C, it will return the token as ID and pointer to symbol table entry for C. Then it will find 2 stars, 1 star, 2 star. Now, it can so here there is a confusion, because here on getting 1 star it has returned maltop as the token, but here getting the first star itself, it could have returned maltop to the parser, but it does not do that. It actually, what the lexical analysis tool does is that it finds the maximum match. So, there is a rule in my language which says that if you get a single star, that is a multiplication, but if you get 2 stars, that is an exponentiation. So, this rule is there in my language. So, the lexical analysis tool, so it will try to find maximum match at this point, and it will find that the maximum match is this one, not this one, whereas at other places the maximum match was the single star. So, at this point when I was looking for maximum match, so this was a single star, because star C does not have any meaning for the programming language. So, that is considered here. So, naturally this here it is a maximum match. So, star star it matches. So, it will return the exponential operator, and then this 2 is a number. Now, the as I said that it will have an attribute. So, attribute value is integer value 2. Now, you look into these 3 places. So, here also it is returning ID. So, here also it is returning ID, here also it is returning ID. At all the 3 places it is returning the same token. Okay. If this token ID is given the number say 45, so at all the 3 places it is returning the value 45 to the parser, but as an attribute it is differentiating between them. In the first place it is returning pointer to E, second place pointer to M, and third place pointer to C. So, all these information are required, like as far as the grammar checking is concerned. So, these pointers are not necessary, but if you are trying to check what are the types of these variables, and if you are trying to generate code for that, then you need to have the corresponding symbol table pointers. Okay. So, for basic syntax checking it is not needed, but for later stages of this code generation and all, so these pointers will be useful. So, that is why this lexical analysis tool, it not only identifies the words and returns the corresponding tokens, it also identifies some attributes that may be meaningful for that particular word and returns them to the parser. Similarly, when it is considering this number, so it is returning the value of the number as 2. So, this is done here. So, this way all these tokens, so they have got some attributes, and these attributes are returned to the parsing phase. There can be lexical errors. So, lexical errors are the situation that errors are out of power of lexical analyzer to recognize. So, this like say this one, say some errors the tool cannot identify, like say this one, in some C language program we have written something like this. Now, so it cannot identify the situation, because this fi, so ideally it seems that fi should be if, okay, but it should not do it automatically, because it may so happen that user has defined a function whose name is fi, and this a equal to fx is an expression. So, value of this expression is passed as a parameter to the function fi, and that will be evaluating the function fi. So, this has got some other possible meaning also, but it is actually if this is made if, then that is the most probably that is the correct one, but the other one, the existing one, that is phi f I and within bracket a equal to f x. So, that is also may be correct. So, we have got confusion. So, the lexical analysis tool cannot handle this type of situation, this type of errors. However, it can identify this as an error, because in my programming language for the identifiers it is said that it should start with a symbol, it should start with a character and then it should continue with characters or digits. Now, this, so no symbol can start with a 2. So, this is not going to be a symbol. So, but at the same time it cannot take 2 as a number, because if it is a number, then after that between 2 and r there should be an operator. So, a number must be it must be separated by at least one blank space. So, that way the lexical analysis tool can identify an error at this point, and it can tell the user that there is an error at this point. So, such errors are recognized when no pattern for lexemes matches a character sequence. So, if you do not find any match, then we can say that there is some problem with this particular sequence of characters that are occurring. So, that is an error. Another possibility is that there may be some foreign characters in my input string, and then the lexical analysis tool, since it knows the alphabet, so it can inform that those foreign characters are there. So, it is not in your language. So, accordingly it can generate some error.